Welcome to this video on operating systems, the software that runs your computer. We'll explore how they work and what makes them essential. So what exactly is an operating system? We will answer that question in this video. An operating system, or OS, is the fundamental software that manages a computer's hardware and runs all the programs on it. To understand the OS, let's look at the key hardware components. First, there's the processor, or CPU, the brain of the computer. Next, we have RAM, or memory, which temporarily stores data for quick access by the CPU. Other essential hardware includes storage devices, like an SSD, the GPU for graphics, the keyboard for input, and the monitor for output. The question is, who coordinates all of this hardware so it works together smoothly? Without an operating system, every application would need to communicate directly with every piece of hardware. This would create a chaotic mess of connections. Direct hardware communication would be too complex, too fragile, and too insecure for modern computing. The solution is the operating system. The OS acts as the middle layer, mediating all communication between your applications and the computer's hardware. The OS is the critical middle layer that organizes the flow between the top layer, applications, and the bottom layer, the hardware. With an OS, applications only talk to the operating system, and the operating system handles the intricate details of communicating with all the diverse hardware components. We now dive into the details of how the operating system actually works. At the heart of every operating system is the kernel. This is the core program that is always running and directly controls the hardware. The OS has four main jobs. It manages processes, memory, files, and devices. The first job is managing processes. Every program currently running on your computer is called a process. If you open your task manager, you can see all the active processes. The operating system monitors their resource usage, including CPU and memory. The challenge is that modern computers run hundreds of processes, but typically only have a single CPU core to execute them. The OS rapidly switches the CPU between processes, thousands of times per second. This is called scheduling. Scheduling is so fast that all applications appear to be running simultaneously, allowing for multitasking. Job 2 is managing memory. Every running program needs memory, or RAM, to hold its data and instructions. The OS takes the total RAM capacity, divides it into blocks, and allocates these blocks to different programs as needed. Each block is tracked and protected by the OS. This memory protection ensures that one program cannot read or write another program's memory. This is crucial for system stability and security. Job 3 is file management. The OS transforms raw storage bits into organized files and folders through a file system. Without the OS, your storage is just a confusing stream of binary ones and zeros. With a file system, the OS allows you to name, open, and organize data in a logical, hierarchical structure of folders and files. Job 4 is managing devices. The OS handles communication with all input, output, and connectivity devices, such as your keyboard, printer, or Wi-Fi card using drivers. A driver is a small program that acts as a translator, allowing the OS to interact correctly with one specific piece of hardware. So how exactly does an application ask the OS for a resource or service? It uses something called system calls. When an application, like a browser, needs to save a file, it sends a system call. The OS then checks permissions and memory, calls the necessary driver, and completes the action, finally returning a success message to the browser. The OS runs in two separate modes to ensure stability and security: user mode and kernel mode. Next, let's explore how an operating system starts up in the startup journey. The boot sequence begins with power on. Firmware runs hardware checks, finds the boot drive, loads the OS kernel into RAM, and then the kernel starts services and the login screen. Now let's look at the different kinds of operating systems in use today. The major desktop OS platforms are Windows, the market leader with extensive software support, macOS, Apple's premium, Unix-based OS, and Linux, the free, open-source choice that powers vast infrastructure. Mobile OSes include Android, Google's Linux-based system for many phones, and iOS, Apple's proprietary system for iPhone and iPad, built from the same core as macOS. Beyond desktops and mobile, operating systems are everywhere. Servers, smart TVs, game consoles, cars, routers, and smartwatches all run specialized operating systems. You can think of the OS like a restaurant manager. Customers or your apps give orders to the manager, the OS, who then directs the kitchen, the hardware. Operating systems are vital because they provide abstraction, manage multitasking, ensure security, and offer compatibility, making modern computing possible. To recap, every computer has hardware that apps need to use. The OS manages processes, memory, files, and devices through system calls. Windows, macOS, Linux, Android, and iOS are all operating systems. Thank you for watching this explainer video on operating systems. Subscribe for more content, and we'll see you in the next one.